We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Okay, my feet are out. Okay, I'm out. Really looks funny out there. See my glove out there, Jim.
Jimmy 4, get back yet.
Good morning, Gordo.
Good, how are you?
How does it feel for the United States to be the new record holder?
At last, huh? Well, we got serious problems here with the coupling memorandum. We're engaged from the issue.
Liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
Hello and welcome. This is Michael Annis, and you're listening to episode 52 of the Space Rocket History Podcast. And now, Gemini-1 Test Flight, Part 2. On March 3rd, 1964, the Gemini spacecraft and booster were at last together on Launch Complex 19 at Cape Kennedy. The first order of business was a series of tests that were run to show all booster systems were working. Next, the spacecraft was hung on a tripod in the White Room atop the launch vehicle erector. The White Room was 4 levels high and was sealed off from the outside world. A constant temperature of 72 degrees Fahrenheit and a constant relative humidity of 50% was maintained to provide a controlled environment for the spacecraft and the upper stage of the booster. An umbilical tower 31 meters high was next to the launch vehicle erector. Its 7 booms supported 31 cables and lines to the spacecraft and the booster. The cables fed electrical power, propellant, and other needs until the moment of launch. Gemini-Titan 1 was scheduled to lift off on March 28, 1964. On March 4th, a pre-mate systems test confirmed that the spacecraft was ready for mating, which meant that the spacecraft to the launch vehicle adapter could be bolted to the booster's upper stage. The bolting effort was delayed briefly when a McDonald worker dropped his wrench on the dome of the oxidizer tank just below the spacecraft. A plastic sheet protected the dome, but the impact produced a scratched 0.95 centimeters long and 0.0038 centimeters deep in the steel surface. The steel was only 0.16 centimeter thick at the point of impact. The impact area had to be burnished to the depth of the scratch, and the tank had to be retested to confirm that the metal was solid. After the spacecraft and launch vehicle were mated mechanically, the next logical step was to make the electrical connections. But first, the booster's status had to be checked in a combined system test. The combined test was successfully completed on March 10th. Next, 3 electronic-electrical interference tests had to be completed to verify that there was no serious electrical incompatibility between the spacecraft and the booster. The test began on Thursday, March 12th. The first try had to be scrubbed, which caused a 4-day delay, but on Monday, March 16th, the test went off without any problem. The excited crew decided to run the second test immediately, but the attempt went awry due to a procedural error. The second attempt on March 19th brought bad news. Some amplifiers in the circuit that controlled the booster's tandem actuators showed electrical interference on the outputs. You may recall the actuators were used to shift the engines to alter the flight path. The test was repeated the next day with the same results. At this point, the Martin engineers pinpointed the problem. The electrical interference was caused by the test equipment itself. Another test the next day confirmed the finding. A conference that evening concluded that the data from the dry run the previous Friday met the intent, if not the precise format, of interference testing. The test equipment was removed that night. The test had taken almost 2 weeks longer than planned. This forced the launch to be delayed until April 7th. But things now began to move more smoothly. On March 27th, a combined systems test and simulated flight procedure showed no serious problems. On March 31st, all the non-flight parts that GLV-1 had carried to the Cape were replaced and the POGO gear was installed. GLV-1 was now scheduled to have its tanks filled with propellant that night as part of a complete countdown exercise, which is called the Wet Mock Simulation Launch. At 9 p.m., as shift workers were clearing the area for the start of filling the tanks, someone saw smoke pouring from a switch at the launch pad. The cause was a burnt-out transformer and switch motor. This forced the test to be suspended because there were no spares on hand and the switch performed a crucial function. The switch was supposed to automatically transfer the launch complex to auxiliary power if commercial power failed. Since the simulated launch was aborted, safety demanded that the launch area be deluged with water in case there was a propellant leak. Workmen found a spare transformer at 1:18 a.m. the next morning and installed it, but a new motor was harder to locate. One was finally borrowed from the blockhouse, but another day had been lost. Propellant loading resumed just before 10 p.m. Wednesday night and finished 4 hours later. The countdown began at 5 o'clock Thursday morning, but now came weather trouble. The Cape was under an atmospheric inversion, which I'm sure all you pilots out there know it is a blanket of warm air above cooler air. This inversion was located near the ground. This inversion would block the upward dissipation of toxic fumes in case of an accident. The countdown was held until 8:30 a.m., when the inversion started to break up. Ground crews then removed the propellant lines leading to the booster tanks, and the count resumed. It followed its normal course until 3 minutes before launch, when a minor problem that was quickly corrected required the count to be recycled to T-5. 5 minutes later, a noon, the count reached T-0, the moment when the booster's first stage would have ignited in a real launch. The test was a complete success, free of spacecraft problems, and marred only by a minor procedural error in the launch vehicle countdown. After a vibration test of GLV-1, the tanks were drained of propellants. A 5-hour process finished at midnight. The Spacecraft Flight Readiness Review Board convened Friday afternoon, April 3rd. A check of items left open from the pre-flight review of February 18th and 19th showed that everything had been taken care of except a circuit breaker not fully qualified. But that was close enough for McDonnell and the board to certify it flight-worthy. Only 2 new problems had cropped up since the earlier review, and both were easily corrected. The board judged all systems ready for flight pending the outcome of the final systems test, a simulated flight scheduled for April 5th, which was completed successfully. Flight readiness of the launch vehicle was reviewed again on April 6th. The Air Force reported 2 problems, one of which turned out to be non-existent. The other involved a missing report of the results of an analysis of a failure in the secondary autopilot. The report was still absent on the eve of the flight, but a phone call confirmed that the problem had been analyzed. Walter Williams convened the Mission Review Board on Sunday morning, April 7th. Spokesman for every group involved in the mission reported everything ready, all systems go. At noon, Williams announced that NASA was proceeding toward a launch not earlier than 11 a.m. Wednesday, April 8th. The final decision for launch came on Tuesday morning at 7:30 a.m. April 7th. The Air Force Space Systems Design Status Review Team for GLV-1 met, took a last look at the launch vehicle, and agreed it was ready to go. That recommendation was passed on to the Flight Safety Review Board at 9 a.m. The board approved GLV-1 for flight and committed it to launch, with liftoff set for 11 the next morning. Preparations for the final countdown were already underway. The first part of the planned 390-minute split countdown started before dawn on Tuesday. That 60-minute segment ended at 5 a.m. when the count was held for 23.5 hours to prepare the spacecraft for final countdown, which entailed installing and hooking up pyrotechnics, running some more launch vehicle tests, and loading the propellants. GLV-1's tanks were topped off at 4:10 a.m. Wednesday morning with about 75 people from Martin, the Air Force, Aerojet, and Aerospace on hand to witness it. 30 systems experts from McDonnell and the Manned Spacecraft Center arrived at the blockhouse at 4:30 a.m. The hold ended right on time, and 1 hour later the final countdown began. No problems were encountered for the entire 5-hour process. 1 second after 11 o'clock Wednesday morning, April 8, 1964, the booster's first stage ignited, which was 1 second later than planned. When reporters asked about the 1 second delay, a joking Walter Williams remarked, quote, "There must be something wrong with the range clock," end quote. Back to the launch. 4 seconds later, the 156-ton vehicle lifted from the pad on that curiously lambent flame so distinctive of Titan's 2 hypergolic propellants. Within moments, Gemini-Titan 1 vanished into the hot Florida sky, beyond reach of human senses, but not electronic sensors. Telemetry data flowed back to the mission controllers at the Cape, telling them that the launch was as nearly perfect as it looked. 2.5 minutes after liftoff, GLV-1's first stage engines cut off after exhausting their 130 tons of propellant and driving Gemini-Titan 1 64 kilometers high and 91 kilometers downrange. The second engine flared into life, and the 4 bolts that held the 2 stages together exploded as they were designed to, cutting the spent first stage loose from the still accelerating second stage and the spacecraft. 5.5 minutes after launch, the second stage exhausted its 30 tons of propellant and stopped. Gemini Spacecraft 1, with the second stage of the Titan II still attached, was 1,000 kilometers downrange and 160 kilometers high, coasting at a speed of 7,888 meters per second, and was in orbit. The apogee was 320 kilometers and the perigee was 160 kilometers. Here's a NASA clip describing Gemini-Titan 1.
During the year of the Gemini program, from January 1964 through January 1965, Gemini moved steadily toward its primary goal of a flight of a 2-man spacecraft. On the 7th of April, Gemini began counting down for the first step. Gemini-1, unmanned, was being fueled for orbital flight. It would not be recovered. The major objectives of this flight were to prove the compatibility of the launch vehicle and spacecraft, to qualify the launch vehicle systems in flight, and to evaluate the launch complex. Checkout proceeded into April 8th. Watched closely would be the performance of the Gemini launch vehicle in the early stages of ascent. It incorporated design changes to correct the longitudinal oscillations encountered in early flights of Titan II. There were no major holes in the countdown. Within 1 second of the scheduled time, Gemini number 1 lifted smoothly off the pad. It rose high above Cape Kennedy, following the programmed flight trajectory for orbit. 5 minutes and 37 seconds later, spacecraft and Stage 2 of the launch vehicle entered orbit as planned. All purposes of the flight were attained. Launch vehicle oscillation was lower than predicted and well within limits for manned flight. GT-1 had now become the 133rd successful major launch of the National Aeronautics and Space Administration.
Everything had gone almost perfectly. There was an excess in speed from the launch vehicle of 7 meters per second that propelled the spacecraft into an orbit reaching out 320 kilometers instead of the planned 299 kilometers. And there was a 3-second loss of signal from the craft during stage separation. It was later determined that the brief communications blackout was caused by charged ions from the separation and startup of the second stage, similar to the blackout during spacecraft reentry. This same blackout occurred in all subsequent Gemini flights. But the main goals were achieved. The booster proved it could do its job, and when combined with the spacecraft, its structure was sound. Walter Williams told the press, quote, "There's no question the objectives were met," end quote. The nearly flawless performance of the launch vehicle elated its sponsors, prompting one of them, Major General Ben Funk of the SSD, to call it, quote, "just completely a storybook sort of flight," end quote. The mission of Gemini-Titan 1 was much shorter than its actual trip. Only the first 3 orbits were part of the flight plan. There were no plans to separate the Titan II second stage, so there would be no retrofire to deorbit. But it was not necessary anyway, since the high drag caused by the attached second stage would speed the deorbit procedure. When Spacecraft 1 passed over Cape Kennedy for the 3rd time, about 4 hours and 50 minutes after launch, the first Gemini flight came to a formal close. The spacecraft had been expected to orbit for 3.5 days, but because of its slightly higher than planned orbit, it actually stayed up for nearly 4 days. During that time, the Manned Spaceflight Network, a round-the-world system of tracking stations controlled from the Goddard Space Flight Center in Maryland, followed the vehicle by radar. Let's take a minute and identify those tracking stations. There were 11 primary tracking stations and 15 secondary stations scattered throughout the world. Primary stations could give direct commands to the spacecraft. Secondary stations were used mostly for radar and telemetry information. The primary stations listed here in alphabetical order were Bermuda, which could confirm orbits and recommend go-no-go decisions. Cape Kennedy, of course. Carnarvon in northwestern Australia, operated by the Weapons Research Establishment. The ship Coastal Century, which was originally a C-1M AVI class freighter. It was considerably modified as a tracking ship. Corpus Christi, located at Rodd Field, Texas. Grand Canary, located 193 kilometers off the coast of Africa and 45 kilometers north of the equator. It was essential for tracking if an abort was commanded. Guaymas in Mexico on the Gulf of California. Kauai, Hawaii, the farthest north of the major islands that make up the state of Hawaii. Houston, the primary mission control center. Point Arguello, about 64 kilometers north of Santa Barbara, which was part of the Navy-operated Pacific Missile Range. And Rose Knot Victor, operated by the Air Force Eastern Test Range. And now the secondary stations were, in alphabetical order, Antigua, a Department of Defense range in the British West Indies. Ascension, also a DoD range station on a British island in the South Atlantic. Canton Island, a small coral atoll about halfway between Australia and Hawaii. Eglin, 76 kilometers northwest of Panama City, Florida, on the Air Force Eglin Gulf Test Range. The Goddard NASA Center, located at Greenbelt, Maryland. Grand Bahama, one of the Bahama Islands, that's British-owned, almost due east from West Palm Beach, Florida. Grand Turk, one of the Turks and Caicos Islands in the British West Indies. It provided radar coverage during the final phase of re-entry. Kano in northern Nigeria, about 845 kilometers from the major seaport Lagos on the Gulf of Guinea. Perth in western Australia, operated by Weapons Research Establishment personnel. Pretoria, north of Johannesburg, South Africa. Range Tracker, usually located in the Pacific west of Midway, and that's operated by the Air Force Western Test Range. Tananarive in the Malagasy Republic. Wallops Island off the coast of Virginia. White Sands, located north of El Paso, Texas. And Woomera in South Australia, at a rocket test facility that was also operated by the Weapons Research Establishment personnel. Now back to the mission. On Sunday, April 12th, during its 64th pass, the steadily slowing spacecraft plunged back into the atmosphere, ending its career in flames over the South Atlantic, midway between South America and Africa. NASA Associate Administrator Robert Seamans commended the Air Force for its successful launch vehicle program. Such a fine performance of the first Gemini mission was a good sign for the missions to follow, and surely enhanced the prospect that Gemini astronauts could be in orbit before the end of the year. But the glow of accomplishment soon faded before the hard work yet to be done. While the launch vehicle was now qualified for manned missions, the spacecraft was not. Despite the gratifying success of Gemini-Titan 1 and some real progress on troublesome spacecraft systems, there was no time to rest on laurels. The target vehicle for Gemini's later missions was still a very large question mark, and Gemini's chronic money woes were far from settled. But for all that, Gemini's future in the spring of 1964 looked much brighter than it had only a few months earlier. The future looked so bright that the long-dormant idea of using the Gemini spacecraft for a lunar mission stirred again. George Mueller, NASA's Associate Administrator for Manned Space Flight, had some reason to be concerned about the outlook for Project Apollo in the spring of 1964. Only a few months earlier, plans for manned flights using Saturn I had been canceled, leaving Gemini as the only possible system for manned orbital flights during the next 2 years or more. Mueller wanted to know if a Gemini lunar mission could be flown. If it could, then a contingency plan was to be prepared for a Gemini flight around the moon in case Apollo suffered a serious setback. A review of past studies strongly suggested that the idea was feasible and that McDonnell should be asked to conduct a more detailed study. But that was not to be. During a tour of the plant in Louisiana where Saturn rockets were built, Werner von Braun, director of Marshall Space Flight Center, told a journalist that Gemini would be able to fly around the moon, but only as a possible project to salvage this country's prestige if the manned lunar goals proved impossible. Whether this was intended to squelch an Apollo rival, the effect might have been predicted. The same factors that had blocked the idea before still held. NASA had too much invested in Apollo, too much money, time, and prestige to really think about Gemini to the moon. Funds, in any case, were tight. On June 8th, Siemens told Mueller there would be no money for study contracts. Any circumlunar mission studies relating to the use of Gemini would have to be confined to in-house study efforts only. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.